Hello everyone, this is Wayne again. Today we're going to introduce the maintenance of our product, especially for our AHF and SVG product. First, we're going to have an overview about the maintenance. So the purpose of the maintenance is to keep the equipment stable through the planned maintenance. So we have to do some routine and periodic check during the whole time. Why we have to do this? First, because of the environment impact. For example, the temperature, the humidity, and the dust will shorten the aging of the product. And also, our main purpose is to reduce the hidden faults and avoid functional decline or shorten the service life. And the third principle is if you have some special environment factors, that we have to increase the frequency of the maintenance. So the whole maintenance loop will be like this. First, you have to do the inspect. Second, you have to confirm the site situation. And third, you have to do the record. And after the record, you have to correct whatever is wrong on site. And after all that, you have to review all the maintenance we have done. And if you have any of this situation, you have to increase the frequency of the maintenance, such as high temperature, frequent start or stop load, and grid load fluctuation, and vibration or shock, or dust or corrosion. Second, we have to go through all the items we have to do in the whole maintenance. First is the weekly inspection. We have to confirm 4 high-risk items every week, such as the cooling fans. This is the most the part that is running all the times, which is easy to malfunction. So you have to check the cooling fans. Now, what part to check is to check the fan's operation, see if it's rotating well, any blocked ventilation dust, or whether ambient temperature stay within the allowed range. And the second part is the installation environment. Check the cabinet and the cable if it's normal or abnormal, and any damage, loose on the installation. Third one is the load. Confirm whether all the current goes through city is within the city range. If it exceeded the city range, it will damage the current transformer. And the last part will be the input voltage. You have to check the input voltage on the module's terminals, see if it's within the range that we allow. After the weekly inspection, then we go to the monthly inspection. The frequency of the monthly inspection will be about every 1 to maximum 3 months. So there are several items that you need to check. First is the module itself. Check the module surface. There are trash, dirt, or dust on the side of the modules. Now you have to power off the modules, then vacuum all the dust in the ventilations, and wipe out the dirty dust with alcohol, and wait for a moment, then power on the module back. And for the second part is the cables. Now the cables you have to notice is a discoloration or the agings or cracked insulations. So if you found any of this part, you have to replace the cables or the connection terminals. The third part will be the air duct or the heat sink. For most of our situation we met is the dust block or the materials that block the ventilations. So you have to clean the air duct or replace the fan if there is needed, such as the fan is giving the alarm. But there is one point that you have to notice. If you visually check all the fan is working well, but the module have the fan alarm, meaning that sometimes the fan is giving the false alarm. At this time you can contact us, we'll guide you how to solve this. And the last part will be the airway circuit, which is the poor contact or the loose terminal screws or the cracked insulations. So if any of this happens, you remove the foreign matters and replace damaged or corroded airway cables. Some safety rules that you have to be very careful with. First one is disconnect the main circuit before you do any movement on our modules. Confirm the main circuit is switched off and no electric shock risk remains. And the second part is wait for 10 minutes. Now, because our modules, SVG or AHF, both have the DC capacitors inside of modules, so you have to wait some time for the capacitor itself to discharge, or otherwise there's the risk of the electric shock. That's why we ask for 10 minutes. And the third part, we will do not disassemble modules. Authorized disassemble of our module may cause the injury or failure on the modules. And remember to clean our modules monthly. This is the best for the fans and other parts to maintain its age. And keep the nameplate readable. The reason we mentioned this part is the nameplate is the only key that relates to the serial numbers and the model, and also any other information that we need for the warranties or the after sales. So please keep the nameplate readable. Next part will be our spare parts. The most related to your end user spare parts is the fans. That the design lifetime of the fans normally will be reached about 70,000 hours. So if considering not all our end user are maintenance fans as we recommended, so the lifetime will be shorter than we expected. So this is the most related part for our end users. So for the spare parts that we have some recommendations. First is to do your asset register, record fan specification, quantity and the installation position, and the replacement date by mode. And if you have anything happen on site, you need to check on fans. Then you go to the on-site verification, check the fan speed, and if the fan has some abnormal noises or the rotation is not well, it's blocked, or the dust. So this is what you have to do on site to check the fans. And for different modules, we have different size of the fans, and we list some of our fans mod here. But if you have any other kind of modules that you need to replace fan, you just can directly contact to us. We'll give you a list for fans. After the check part and the recommendation, now we have go to some troubleshoot on our alarm or faults on site we normally met. First is the software faults. First part is the overheat or the fan errors. Those two are actually related. Sometimes if the overheat, the fan alarm happens, normally come with the overheat. Now the fan error is come directly from the fans. We have the fan errors that was directly connected to our DSPs. So if the fan is giving the alarm, then our module will give the fan alarm. But notice that sometimes when the fan is at very low speed and the voltage on that fan is not stable, so sometimes the fan is actually working very well, but the fan will give the false alarm. If you met this situation, please contact us. And the overheat is because of the temperature exceeded the protection parameters on the IGBTs, so it will give the overheat alarm. So for this kind of alarm, you have to check the fan working well, the speed, or if it's blocked, and the radiator's dust, clean all the ventilations, or replace the fans. For one thing is, if it's a newly installation per site, remember to check you have removed all the yellow stickers on the ventilations. And the second part will be frequency, grid low voltage and grid over voltage. Check the grid frequency, voltage, and phase varying and fuse conditions. That is related to the actually from the site and the parameter settings. If you check the input voltage, input frequency is normal, but the module is giving this kind of alarm. You have to check all the parameters that's showing on our HMI if it's matched to the real situations. If it did not match, then contact us. Third part is the DC low voltage, DC over low voltage, and DC NU. That is the DC voltage related alarms. That is our DC capacitors. First, normally this kind of alarm relates to the load sharp or the grid voltage peaks and all the components faults. If they map this alarm, you can reset it for once, then inspect the parameters and the hardware if this alarm repeated it. And this part is the over IA and IB and IC. This is actually indicated to the current. It has the current over the protection parameters that we have set. And first, if it happens just once, you can reset it first. And if it repeatedly giving the overcurrent, you have to check the protection parameters and settings and hardware status. This part you have to contact us to help you to do the checkings. Also the power error. Power error is the internal power supply have some alarm. And if you map these power errors, you can directly contact us. Then we goes to the hardware faults. At least some typical hardware faults. First is the IGBT over temperature. We have to introduce that in the above power point. That case, the fan is not working. All the yellow stickers, you have to pay attention. And if the ambient temperature is high enough, the fan is not as efficient as it's normal. And the second part is about the incorrect sampling current. Check the sampling circuit and CT's sampling board, all the control board. And if the LCD, which is our HMI, is normal, check the power connections or the HMI has damaged, or the control board have some issues that the communication between the LCD and the control board is not normal. And for the modules, the fuse, if the modules fuse burn out, we have to disarm all the modules. You have to report to us. We will tell you to disassemble the modules, and we have to inspect all the PCB board, and maybe you have to change the IGBT board. And the communication of normally between the HMIs and the module itself, or between the if you got multiple modules, or maybe between the modules. So have poor communication situations. That is, you have some EMC interference between the communications, or the connection is not that good. So check this part. Recommend to use the shield cables for the communications. And the power supply is not abnormal. We have to check the inside our power supply PCB in our modules. In this part, you also need to contact with us. Thank you. This is all about maintenance on our products. That is just some typical situation I just introduced. And we have some detailed instructions in our user manuals. If you want to learn more, please go to our user manuals. And if you have any other questions, contact us with the sales@koepower.com.